Okay, so this unit on transformations, what that means is it's just the way shapes are moving on a coordinate plane. So there's 4 different types we're going to talk about, but one thing we need to know about those transformations before we get into those is the difference between congruence and orientation. So congruence means 2 figures are congruent if they're the same size and same shape. So that's the main thing you need to remember. Same size, same shape. If a pre-image, so that's the first image before its transformation, and a pre-image, so that's the second, are the same size and same shape, the image has congruence. You would say it has congruence. So the only transformation we've talked about so far is dilation, and dilation is the only transformation that does not preserve congruence. So the size changes. That's what dilation means. Then the other thing you need to know about is orientation. So, and that means the way or the direction a shape is facing. So if a transformation causes a figure to change the direction the figure is facing, the orientation has changed. Okay, so if a shape turns or if it's reflected, if it's facing the opposite way after the transformation. So say it's facing the left, the pre-image is facing to the left, and after its transformation, now it's facing the right, the orientation has changed. That's what that means. So transformations that keep or preserve orientation are translations, which means your shape slides. We'll talk about that in a little bit. Dilation, which we talked about, and that's an enlargement where the shape gets bigger or it gets smaller. So those are the only 2 that keep orientation. They're going to be facing the same direction after they transform. And then transformations that do not preserve or keep orientation. Reflections, that means your shape is going to flip across a line of reflection. And rotation, that means your shape is going to turn. So a transformation is a type of function that describes a change in the position, size, or shape of a figure like we talked about. And so just a brief overview of all the transformations we're going to talk about. The first one is translation, which means translation, think of a slide. So you're just sliding a shape. You're not turning it. You're not doing anything different to it. You're just sliding it up, down, left, right. The figure can be slid up, down, or sideways. However, the size, shape, and orientation of the figure remain the same. So it's congruent. So down here it says state of the figure below represents a translation by writing yes or no. So this first part, these are all actually translations. So I'm just going to label if they preserve congruence and orientation. So A, the arrows are facing the same direction and they slid. They didn't, the size didn't change. So I would say it's congruent and it preserves orientation. B, same thing, from the pre-image to, I guess we'll say, this is pre-image to the image. The size doesn't change, so that means it's going to be congruent. And it would be hard to tell, but it just slid this way, so it didn't turn or anything. So we're going to say the orientation is the same, even though it's a circle and it's really kind of hard to tell. C, same thing. The size doesn't change from pre-image to image, so that means it's congruent. And it's still facing the same direction, so the orientation stays the same. Then down here at the bottom, just some examples of dilations, and we're going to decide if it's an enlargement or a reduction. Remember, dilation always changes congruence, so it changes the size and shape unless the scale factor is 1. Okay, remember the dilation changes, it gets larger or smaller based on the scale factor. So if your scale factor is bigger than 1, then it's going to get larger. It's an enlargement. If your scale factor is smaller than 1, then it's a reduction. That means your shape is getting smaller. But if your scale factor is 1, then it's going to stay the same, because anything you multiply by 1, what happens to it? Nothing. 2 times 1 is 2, 3 times 1 is 3. It remains the same. So on number 1, remember your pre-image also. Your pre-image will be labeled with just the regular letters like N, P, W, V. And so then your image, whatever happens after your transformation, remember we put that little hash mark. N prime, P prime, W prime, V prime. That's what that little hash mark means. Just to let you know that that's the transformed shape. That's the image, not the pre-image, or the second shape. So we've got our pre-image here, and our image is this larger one out here. So what happened to it? It got bigger. So that's an enlargement. On number 2, my regular letters without the little hash mark is this shape, so that's your pre-image. And this larger one out here with the prime, with the hash marks on all of them, that's our image, so that's our second one. So it got bigger, so that means it's also an enlargement. And then number 3, our pre-image is this one with just the regular letters, no hash marks out to the side, so pre-image. And then my tiny one over here has all those hash marks, so that means it's my transformed image, my second image. And it got smaller, so that means it's a reduction. So, and if we wanted to, we could go through and figure out the scale factor for each one, but just remember that if it's an enlargement, it's got a scale factor of a number greater than 1, or wait, scale factor greater than 1. Same thing over here. An enlargement, that means the scale factor is larger than 1. And if it's a reduction, then our scale factor is less than 1.